I'm debugging a new, very high-level language. And I've got a programming language workbench. I've hacked on the REPL, trying to get a heads-up display of how things are compiled. At the bottom is an example program I'm trying to compile. It's not very spectacular. In my world, the async defs are handlers that accept a data structure which describes a class of object called A and an incoming message. The handler is supposed to do something with the message in return. There are two auxiliary functions necessary. You need to install a component which registers a template for the component. Then you need to instantiate the component possibly more than once. The template contains a name or base name for the component, class or instance data, and a reference to the instantiator. The instantiator takes the current registry of all components that have been registered. It takes the owner of this component. This is all layered. So only the top layer has an owner of nil. Everyone else is owned by somebody else. It has an incoming name and template data, which is like class data. That probably needs to go away at some point, but not now. So in here, I generate a name by gensimming a symbol that starts with an @sign. In this particular case, the component is a monitor component. I chose the name for the monitor component, and we'll tack onto it a subscript like 1, 2, 3, 4, 5 that will help identify the instance. And then we turn that component into a leaf component and give it the name with the ID. We give it the owner. That's a Python thing. It should actually be a phi. Let's see if I can do that. Counter dot. Here I've already done this before. So we'll copy that none thing and replace it here. And the leaf also contains the handler for that leaf. When you instantiate, you register the component, and then in the diagram, when you use the component, each instance gets instantiated slightly differently with a gensim name, and it points to the handler code. The handler code, whenever it gets called, that's really like an async def in Python, gets called with its enclosing class and the current incoming message. There's only one message at a time to handle. Here we get the string representation of the data contained in the message, and we do the assignment to something called a local variable called s. We also create another local variable called I, which converts the whatever is in the message datum to an integer. And then we go into a while loop, says while I is greater than 0, we cons a blank onto the string. This is inefficient and can be done better, but at this design stage, I'm just doing an MVI, minimum viable implementation. I don't care how inefficient it is. Later, we'll add efficiency. When we're done consing spaces onto the front of it, we're just trying to indent by the number of indentations, we print the string. And the monitor, that's all it really does. The monitor component concatenates blanks onto the front of the string to show indentation. So now we'll see how this compiles using the current version of the code. The syntax of the VHLL is here. It's kind of a BNF based on Home.js. It goes through stages. We inhale the code, modify it using internalize.home. Then syntax check it, which really just runs it through home and declares any errors. We do semantics checking, looking for ways things are used and declaring errors. If we see them used incorrectly, then we transpile the RT to common list. Then we run it through a peatholer, the text-to-text transpiler. It looks for simple patterns, gets rid of them, and then we exhale the common list code. We decode it first, then we uninternalize, and then we indent it. The uninternalizing isn't very spectacular. It just takes away extra Unicode brackets added around symbols and other things. We start up the REPL, make Python 3 choreographer.py, web server started, reload the GUI. The Python choreographer is looking at a bunch of watched files. If I change any one of these files, it will recompile everything and it should then show me the stuff in the REPL up here in the GUI. So let's go to monitor. Just change that up. Delete the space. We started it. Here we're seeing it goes to begin. We'll go to this file. We'll add some white space, delete the white space, save, and immediately over here we see begin. Here we see nothing. The REPL will respond instantaneously. It's actually taking 5 seconds or more. I don't know if I care to fix that. And it generated common list in Python code. So far hasn't generated other types. Hoping to do JavaScript and WASM. If we look at the code, define function, install, parameter reg, call register component with these parameters. It's been turned into list with comments that say what line it came from in the original file. And in here it does the same thing in Python. The handler is the interesting bit, the assignment to the declaration of a local variable and then assign a value to it. It assigned the value and gave the line number, but it didn't declare the local variable, so that's something I'm going to look at.